Antarctica is one of the most extreme environments on Earth, where survival depends on precise adaptation to cold, wind, and isolation.
Temperatures here can drop below -40 degrees Celsius, creating conditions that challenge even the most resilient forms of life.
Relentless winds sweep across the frozen landscape, increasing heat loss and making the environment even more hostile for exposed organisms.
Despite these conditions, large colonies of penguins continue to survive, relying on behavioral and physical adaptation.
This is the Adélie penguin, a species uniquely adapted to thrive in one of the coldest and most unforgiving habitats on the planet.
If an egg were placed directly on the frozen surface, it would immediately begin losing heat through conduction into the surrounding ice. This rapid heat loss can lower the egg's internal temperature beyond viable limits, preventing proper embryonic development and leading to failure.
To prevent this, penguins rely on a surprisingly simple but highly effective solution built from materials available in their environment. The Antarctic surface is not stable, as ice can melt slightly under sunlight and refreeze repeatedly over short periods of time.
This melting process creates thin layers of water that can accumulate around eggs, increasing the risk of chilling and structural instability. When temperatures drop again, that water quickly refreezes, forming uneven and unstable surfaces beneath developing eggs in this environment.
Exposure to both moisture and freezing cycles creates dangerous conditions for eggs that require stable temperature and dryness to survive.
Penguin eggs are highly sensitive to environmental changes, especially fluctuations in temperature and prolonged exposure to moisture or direct ice contact.
Direct contact with ice dramatically increases heat loss, making it difficult for the developing embryo to maintain the warmth necessary for survival. This process is known as conduction, where heat moves from a warmer object to a colder surface, rapidly cooling the egg.
To solve this problem, penguins developed a simple but highly effective construction strategy using materials available in their surroundings.
They begin by collecting small stones scattered across the rocky Antarctic coastline, carefully selecting pieces suitable for building a stable structure. Each stone is transported individually, often over short distances, requiring repeated effort and precise placement during the nest building process.
Over time, these stones are arranged into a circular structure that gradually forms a raised platform above the surrounding ice.
This structure becomes the penguin's nest, designed specifically to protect the egg from environmental hazards found in this extreme habitat.
By elevating the egg above the ice surface, the nest significantly reduces direct contact with cold ground, minimizing conductive heat loss.
This separation creates a thermal barrier, slowing the transfer of heat away from the egg and helping maintain internal temperature stability.
Even a small reduction in heat loss can dramatically improve the survival chances of the developing embryo inside the egg.
The raised structure also prevents meltwater from reaching the egg, keeping it dry despite frequent cycles of melting and refreezing.
Maintaining dryness is essential, as moisture combined with freezing temperatures can severely damage the egg and reduce survival rates.
Unlike loose snow, stones provide structural stability, allowing the nest to maintain its shape even under strong Antarctic winds.
This stability ensures that the egg remains securely positioned, reducing the risk of displacement or exposure during harsh weather conditions.
Together, these simple structural advantages form an efficient survival system built entirely from available natural materials.
However, the nest alone is not sufficient to ensure survival in such an extreme and constantly changing environment.
Penguins rely on collective behavior, forming dense groups to reduce exposure to wind and conserve valuable body heat. From above, these groups appear as tightly packed clusters, minimizing surface area exposed to the surrounding cold air. This formation helps retain heat within the group, creating a microenvironment significantly warmer than the external conditions.
Penguins continuously shift positions, allowing individuals on the outer edges to gradually move toward the warmer center.
This rotation ensures that no single individual remains exposed for too long, distributing thermal stress evenly across the group. Warm air trapped between bodies and reduced wind exposure together create a highly effective biological insulation system. This coordinated behavior represents a collective adaptation, where survival depends not only on individuals but on the group as a whole.
Despite these cooperative strategies, essential resources such as stones remain limited, creating competition among individuals within the colony. Some penguins attempt to improve their nests by carefully taking stones from nearby structures when opportunities arise without immediate confrontation.
These encounters may lead to brief conflicts, as individuals instinctively defend the materials essential for protecting their offspring.
Nests with stronger structure provide better insulation and protection, directly increasing the probability that an egg will survive to hatching.
As development progresses, the embryo reaches a critical stage where successful incubation allows the chick to begin emerging from the egg.
Successful hatching represents the outcome of precise environmental adaptation, where both behavior and structure contributed to reproductive success.
In one of the harshest environments on Earth, even the simplest architectural solutions can become the foundation for sustaining life.
As development progresses, the embryo reaches a critical stage where successful incubation allows the chick to begin emerging from the egg.
Successful hatching represents the outcome of precise environmental adaptation, where both behavior and structure contributed to reproductive success.